Hello everyone and welcome back to Willow's Notes. Today is day 5 of our Hardy Weinberg practice videos. Make sure you watch the previous ones as well as the upcoming ones. I will place all of them under one playlist. Now let's start with question number 5. Let's start by reading the question. 780 flowers within a small population are pink and 70 are purple. Knowing that purple is recessive, so purple is recessive, what is the frequency of the purple allele? Frequency of allele. So we're thinking P and Q, right? Not P square, not Q square. We want the frequency of the allele. And which frequency? The purple. And it's given that purple is recessive. So immediately, which letter represents the recessive allele? Q. So we want to find Q. What is Q? Now let's read our givens. 780 flowers within a small population are pink. And I'm going to use a purple highlight to highlight 70 are purple. The first thing you should notice is that these numbers are not frequencies. 780 flowers are pink. 780 flowers out of how many flowers are pink? We don't know. We don't have a frequency. So when you have a question, when the total number is not given, find it. So the first step is going to be, let's write it here in the corner, 780 plus 70, which gives us 850. So that's the total number of flowers within this population. Now we can find Q square. What is Q square? Q square is the frequency of the homozygous recessive individuals. In this case, who are homozygous recessive? The purple flowers, because purple, it is given that it is recessive. So there are 70 flowers that are purple, but 70 out of 850. So that's the value of Q square. And that's equal to 0.08. Once we have Q square, all we need to do is find Q, which is equal to square root of 0.08. So the take-home message of this question is that if you don't have the frequencies as a given, you can find them. All you need to do is find a total number of the individuals, and then you can find Q square. Now, you might say, why didn't we use 780? See, 780, let's write that. So 780 out of 850. This value doesn't represent P square. It represents the frequency of the flowers that are pink, right? Because pink is dominant, this value represents P square plus 2PQ. Because the flowers that are pink could be homozygous dominant, P square, or could be heterozygous, which is 2PQ. And that's why we did not go that route. Furthermore, the question asks for Q, and of course it makes way more sense to find Q square and then just find Q. And this was it for today's question. I hope you found it easy, and I'll see you in the next one. Bye!